Hi everyone, I hope all of you are doing fine and working hard for your NEET exam. Now today we are going to revise with one very important topic in our electromagnetism. We'll start with our chapter electrostat. Always remember, this is an important topic. Minimum 3 questions are asked from here. So we'll start with this chapter. Now as you can see, this chapter starts with basic concept of electric charge. So first we'll study about property of electric charge. What are the various important properties? Actually we have many properties of charge, but the properties of charge which will be used in your NEET exam, which can be asked directly in your NEET exam, I'm just talking about those two properties. So first property of charge, which is known to everyone, we're just revising this thing, that is your charge will be always quantized. Quantized means your charge will be always integral multiple of charge of electron or charge of proton, because minimum possible charge is charge of electron or charge of proton. So that's why we say charge is quantized, and from here only we get a very important result, that is charge of every body can be written as Q will be equal to plus minus Ne. If it is positive charge you will take plus, if it is negative charge you will take minus. N represents number of proton or electron and E represents charge of proton or electron. So questions are asked from here. They will give you total charge and they will ask you find the number of protons or electrons needed for that charge. So you can use this result. So first property which is important for our NEET exam, that is charge of every body is always quantized. Whatever the charge any body will have, that charge will be always integral multiple of charge of electron or charge of proton. So from there we get Q equal to plus minus Ne. N represents number of proton or electron. E represents charge of proton or electron. Now let's move to next important property. Charge is invariant. What is meaning of invariant? Means charge will not vary. That means charge will not depend on observer. Whether your observer is in inertial frame, whether your observer is in non-inertial frame, whether your observer is at rest, or whether your observer is moving, or whether your observer is flying, doesn't matter. Value of charge that a body will have, that will be always fixed. That is the meaning. Charge is invariant. That means do not depends on observer. So these are the two important properties of charge. First property, charge is always quantized. Second property, charge is invariant. It will not depend on observer. Now from these two properties, what question can be asked? So numerical asked will be based on your first property. For example, you can see here, they have given you, they are asking you find the number of protons needed to get a charge of 100 Coulomb. That means Q is given, and they are asking you find number of protons. So obviously charge is positive, so that's why I will be taking plus. So Q will be equal to plus Ne. You can put the value of Q, E you are knowing, from here you will get the value of N. So this is what we have got from properties of charges. Now we will move towards our second important topic in electrostat. We will talk about Coulomb's law, and this is a very important topic, is known to everyone. We are just revising this. Now what Coulomb's law tells you, if you have two charges Q1 and Q2 which are separated by distance r, then they will have force between them. If they are of same nature, force will be repulsive. If they are of opposite nature, force will be attractive. And value of that force in vacuum, if medium between them is vacuum, then value of that force you can write as 1 by 4 pi epsilon naught Q1 Q2 upon r square. And this 1 by 4 pi epsilon naught is K, that we represent also as K, that is 9 into 10 to the power 9. But once you will take these charges in a medium, net force between the charges will be reduced, and value of that force between the charges in a medium will become 1 by K times. That is, force in medium will be equal to force in vacuum by K, and this K is known as dielectric constant. So always remember, dielectric constant is the factor by which, obviously if you have two charges in vacuum, interaction between the charges will be maximum, force between them will be maximum, that you have got here. But once you will take the charges in a medium, medium will interact with the charges. So net interaction between the charges will be reduced. So value of force between them will be reduced. So the factor by which force reduces when you take a charge from vacuum to a medium, that factor is known as dielectric constant. So F in a medium will be equal to F in vacuum by K. Now from here you can find dielectric constant of the medium. Dielectric constant of the medium, you can do this from here. So dielectric constant of the medium will become force in vacuum upon force in medium. And from here if you put the value, you will find permittivity of a medium. That is, epsilon of a medium will be K times of epsilon naught. And from here also you can find K as epsilon m by epsilon naught, and this quantity is also known as epsilon r, relative permittivity. Now one more thing is there, one relation we can get from here. For same value of force, if you have two charges in vacuum, then you are again taking the same two charges in a medium. For your force to remain same, distance in medium should be less than distance in vacuum. So R in medium will be equal to R in vacuum by root K. This is a direct result which can be asked. So what I told you here, if you take the two charges from vacuum to a medium, net force between them will be reduced. The factor by which it reduces is known as dielectric constant. So force in medium will be equal to force in vacuum by K. So K will be force in vacuum upon force in medium. And from there we can also write epsilon of a medium as K times of epsilon naught. So K will be also epsilon of medium upon epsilon naught. That quantity is also known as epsilon r. And for same value of force in medium and in vacuum, this is the relation. That is distance in medium will be equal to distance in vacuum by root K. Now we will see some numericals based on Coulomb's law. So as you can see, this is a previous year NEET question, and last year only this question was asked. So just see how to do this question using Coulomb's law. In this what they are saying you two charges Q and minus Q are separated by some distance, has force F between them. If 25% of charge of Q is transferred to minus Q, find the new value of force between them. So how to solve using Coulomb's law? It's again a very simple question. We can solve easily with the help of Coulomb's law. So what I will do for this question, I can simply say, sir, initially what is given, sir, two charges, and just see how we are solving. So initially, sir, you have two charges Q and minus Q. So you can write, obviously force will be attractive, value of that force we can write as KQ square upon R square. This is the value of force F which is given in the question. Now what you said, 25%. 25% means Q by 4. Now 25% of charge of Q is transferred to minus Q. So Q by 4 of this Q is transferred to this. So what will be its final charge now? If you transfer Q by 4, Q it was having, Q by 4 is transferred. So its remaining charge will be Q minus Q by 4. That is 3Q by 4. And this charge got that charge. Its charge was minus Q. It got plus Q by 4. So how much its charge will become? Its charge minus Q plus Q by 4. That its charge will become minus 3Q by 4. So now you can find new force F dash between them. That again you can find K Q1 Q2 upon R square. So value of that force will come. 3 into 3 will give you 9. So this will give you 9 KQ square upon 16 R square. Just you are doing Q1 Q2. So from here F dash will come 9F by 16. Now let's move to next question. So this is a simple question asked last year only in your NEET exam. Here they are asking you find the value of angle alpha. So you can find very easily. They are saying you these two charges are in equilibrium. Charges are QQ, masses MM. They are asking you this alpha. So if you see this charge, on this charge how many forces are acting? One force acting will be its mg. One force will be repulsive force due to this. You can see repulsion will be there. That is electrostatic force. I am representing as F. And another force will be tension in the string. Now if this charge is in equilibrium, that means all these forces must balance each other. Now from here you can break the tension into its component. If this angle is alpha, this angle is also alpha. So if it is in equilibrium, that means T cos alpha. You can say this is your T, this is alpha. So T cos alpha must balance mg, and T sin alpha must balance this force F. So from here we can say T cos alpha will be equal to mg, and we can say T sin alpha will be equal to F. If you divide these two, in this divide this, you will get tan alpha will be equal to mg by you will get tan alpha equal to F by mg, and you can put the value of F, k q1 q2 upon r square. So this is how we can get some numericals based on Coulomb's law. Now let's see one more question, two more questions based on Coulomb's law. So this is again a very important type of question, can be asked directly in your NEET exam. Already this question has been asked in JEE Mains exam. So important situation. If you read the question, they are saying you two charges Q and Q, two charges Q are separated by distance r. Find the value of charge placed at midpoint so that entire system will be in equilibrium. So actually what is happening in this question, understand the solution. They are saying you two charges are there. Both charges are Q, Q, and obviously they are separated by some distance r. They are asking you, if you see right now both will have repulsive force. So they will not be in equilibrium. So that's why they are asking you what should be the value of charge that will be placed at midpoint so that entire system will be in equilibrium. So for example, if you put some charge here, now whole of your system has to be in equilibrium. So we have to calculate the value of this charge Q. Always remember, you no need to think about this Q. If you are placing at the midpoint, since charges are equal and nature is also same, so this Q will be always in equilibrium. But you have to make these charges also in equilibrium. That is the meaning of entire system will be in equilibrium. That means this must be also in equilibrium, this must be also in equilibrium. That net force on both of them will be zero. Should be zero. So I will say like this. Sir, how it is possible? If you see, this charge was already having repulsion due to this. That means repulsion means due to this charge already it was having force like this. If it has to be in equilibrium, that means someone has to balance this repulsive force, and that will be done by this Q which you are placing here. That means this Q must be negative. Then only you can see this Q will have already repulsion due to this Q. If it has to be in equilibrium, someone has to balance this repulsive force. Who is that someone who can balance force due to this charge Q? That means this Q must be negative. Now second thing, sir, how to get its value? Value can get very easily, because this force F and this force which this will have attractive force F dash, these two must be equal. If you equate from here, you can say, sir, F dash will be equal to F dash you can write, that is the repulsive force due to this Q. F dash you can write due to attractive force due to this Q, that is K Q upon this distance was r, you have placed at midpoint, so r by 2 whole square, and F will be repulsion due to this capital Q, so that will be coming as K Q upon r square. From here if you will solve, you will get the value of small q, and value of a small q will come q by 4. But this is not your answer, because here q by 4 will be also present in option, minus q by 4 will be also present in option. You have to put the nature of charge also. Already you know this charge must be negative, so that's why answer will come minus q by 4. Now based on the same concept, we have one more question. Here three charges are placed at the three vertex of an equilateral triangle. If you see, this is an equilateral triangle, and they're asking you what should be the value of charge q placed at centroid, so that whole of entire system will be in equilibrium. Again, it will be saying, sir, for whole of the system to be, no need to think about this charge. This will be already in equilibrium. You have to think about these individual charges. It will be saying, if you take any of the charge, let's take this charge. It will be saying, sir, this charge is already suffering repulsion due to this. You can see some repulsive force will be there. Due to this also, some repulsive force will be there. F angle 60 degrees, so resultant will come root 3F. Now, if it has to be in equilibrium, someone must balance this repulsive force. And who is that someone? That is this Q here. That means this Q must apply attractive force F dash. That means again I can say this Q must be negative. And if it is in equilibrium, this means this F dash will balance this root 3F. So again you can equate F dash will be equal to root 3F. F dash you can find due to this. You know this distance a by root 3. So from here you can get, and you will be getting from here, if you put the value, that is k q upon a by root 3 square will be equal to root 3 times of k q square upon a square. That is this f and this f. Distance is a. Now if you simplify from here, you will be getting small q as q by root 3, but again this is not your answer. You have to put the sign also. It must be negative. So final answer will come here. So this is how we can talk about some questions based on Coulomb's law. Now again we are going to talk about one more topic with the help of Coulomb's law. Because sometimes questions are asked where they will give you two charges and they will ask you where null point will exist, where neutral point will exist, where point of equilibrium will exist. So always remember, I think everyone knows, null point means point where net force will be 0, or you can say where net electric field will be 0, or you can say electrostatic force will be 0. Null point means net force 0, net force also 0 means equilibrium, or you can say neutral point. So same point has got three names. Sometimes they will ask you find the location of null point. Null point means net force 0. Find the location of neutral point, same as null point, net force 0. Find the point of equilibrium, again net force will be 0. So you have to find that thing. And for that one method is there. I think everyone knows how to find location of null point. If charges are of same nature, someone is saying plus q 4q, plus q plus q. If charges are of same nature, then null point will exist between the charges. Where it will exist, I will tell you. With the help of example, I will tell you how to find exact location. But first you must know whether it will exist between the charges or outside charges. So if charges are of same nature, for example, both charges are positive or both charges are negative, null point will exist between the charges. If charges are of opposite, so that is first point. Same nature of charge, null point will exist in between the charges. If charges are of opposite nature, for example, one charge is positive, another charge is negative, or one charge is negative, another charge is positive, then null point will not exist between the charges. It will exist outside the charge. Outside the charge having lesser magnitude. So this is the rule. So what you learned, null point means point where net force will be 0, where field will be 0, that point is also known as point of equilibrium, that is also known as neutral point. Now if charges are of same nature, null point will exist between the charges. If charges are of opposite nature, null point will exist outside the charges, outside where close to the charge having lesser magnitude. Now just see how to do this. If you see in this question, they will ask you, two charges are there, as you can see, q and 4q separated by distance d. They will ask you, find the distance of null point from charge q, or find the distance of null point from charge 4q. So always remember, first you must know where null point will exist, and for that this method will be used. You can see q 4q, charges are of same nature, null point will exist between the charges. between the charges, means between q and 4q, somewhere it will exist. So you can assume, so let's assume it will exist at distance x from here. So from here distance will become your d minus x, because total distance was d. Now you can balance the force. You can assume one q dash is there. So how much force this will exert, how much force this will exert, you can balance the force. Then only net force will be 0. That is the meaning of null point. So force of this, that is k q dash upon x square, that will be balanced by force of this, k 4q into q dash upon d minus x whole square. Now from here you can simplify and you'll get x equal to d by 3. So this is how we got. Now see the next question. This will give you more idea. Now if you see, charges are of opposite nature. One is q, one is minus 9q. You tell me null point will exist between the charges? No sir. If charges are of opposite nature, null point will exist outside the charge having lesser magnitude. Who has less magnitude? This q. You don't have to see this minus, you have to see the magnitude. So q has lesser magnitude. That means null point will exist somewhere here. And they will ask you find the distance of that null point from charge q. Again you can assume that distance to be x. Again you can balance the force. Due to this k q, you can place one charge q dash if you want, k q dash upon x square, that will be equal to, will be balanced by force due to this, that is k 9q into q dash upon, how much distance will now become? This is already d, this is x. So this will become d plus x whole square. You can solve this, you'll get the answer. So questions are asked to find location of null point, which you can do very easily. Null point means point of equilibrium or neutral point. This is the process that you have to get. If charges are of same nature in between, then balance. If charges are of opposite nature outside, then again you can find the force and you can balance. So this is the method to find location of null point. Let's start with electric field. I think everyone knows. Due to every charge and charge system, we get electric field, and we define, as you can see, electric field is defined as electrostatic force per unit charge. E will be equal to F by Q. Many times F is given, so you can find electric field with the help of F by Q, or many times E is given, so you can find F also. So electric field will be equal to force per unit charge. If electric field is given, you can find force also. F will be equal to Q into E. Important result, force will be equal to Q into E. Now we will see some situation where we will talk about value of electric field. For example, if you see a point charge, if I am talking about a point charge, value of electric field due to point charge will come kq upon r square, or you can say 1 by 4 pi epsilon naught q upon r square. You can just put the value of F. F by Q will give you the value of electric field. So this field will come. Now someone will say, sir, we will have two types of charges. One may be positive, another may be negative. So what will be difference? So always remember, if you have positive charge, then electric field produced will be away from the charge. You can see here, this is a positive charge. Value will be same, kq upon r square, 1 by 4 pi epsilon naught q upon r square. But if your charge is positive, then field produced will be away. If your charge is negative, then field produced will be towards. So this is, so value of electric field due to a isolated charge q will be 1 by 4 pi epsilon naught q upon r square. If it is positive charge, field will be away. If it is negative charge, field will be towards. Now value of this is again important. Sometimes questions are asked where they will ask you value of electric field due to a ring on its axis. At center, field will be 0 because charges will be situated symmetrically, so all charges will cancel the field. But on axis, field will not be 0. So value of electric field on the axis of ring at a distance x on its axis from center will be, this is a formula which you have to keep in your mind. That is, on the axis of ring, value of electric field will be 1 by 4 pi epsilon naught qx upon r square plus x square to the power 3 by 2. This is the value of electric field on the axis of ring, 1 by 4 pi epsilon naught qx upon r square plus x square to the power 3 by 2. What is x? Distance on the axis. Now we will talk about electric field due to again two important structures. Normally we get these structures in Gauss Law, but since we have studied about, since we are revising these things, so we'll talk about electric field due to solid sphere and due to hollow sphere here only. So let's see here. So they will ask you value of electric field due to solid sphere. You can see this solid sphere here. So for solid sphere again 3 points will exist. One will be outside if your r is greater than radius. If you see distance from center is greater than radius, that means outside. If r equal to r means surface. If r less than r means inside. So they will ask you these values also, and they will ask you graph also. Graph is especially very important for your NEET exam. And last year also in NEET question was asked from here. So you must know how solid sphere behaves and how hollow sphere behaves. So if I have a solid sphere, if that solid sphere has charge q distributed uniformly throughout its volume, then value of electric field outside kq upon r square. Surface r will be equal to r, that is kq upon capital R square, but inside value will change, and this value is obtained with the help of Gauss Law, which we don't need right now. So you have to keep this value in your mind, that is electric field inside will come kq upon r cube into small r. If you see this and this two result, here your variation is inverse, but inside variation is direct. So from here if you draw the graph, inside till your r is equal to r, before this your r will be less than r, that is your inside. You can see variation is linear, that means that's why you are getting graph as a straight line, and this portion is representing you region inside. But after this outside, variation will be inversely proportional, which you can see here. So value of electric field outside kq upon r square, inside variation will be different, kq upon r cube into small r. That means inside variation will be straight line, outside variation will be inverse. So that's why you got the graph. Now let's talk about electric field due to hollow sphere. So hollow sphere will be also same, but inside hollow sphere no charge will be there. So that's why inside no field will be there. Otherwise outside same variation, kq upon r square, surface again kq upon r square, but inside electric field will be 0 by Gauss law. So you can say inside, because since it is hollow sphere, so nothing is present inside. So inside no charge will be there. If no charge is there, what will be field inside? Inside field will be 0. That's why you can see the graph. From here to here, your 0 value is there. But as you reach r equal to r, that means you reach to the surface. After surface again you will get same behavior, because outside same behavior, but inside field will be 0. So what is the difference? For solid sphere, if you have a non-conducting solid sphere having charge uniformly distributed throughout its volume, field will be coming inside. But if you have a hollow sphere, inside field will be 0. So for solid sphere, outside kq upon r square, surface kq upon capital R square, but inside solid sphere kq upon r cube into a small r, straight line, then hyperbolic decrement. For hollow sphere, outside same value kq upon r square, surface same value kq upon capital R square, but inside no charge is there, so no field will be there. So this is the graph also important, values also important. Now we are going to move towards motion of charge in external field. If some external field is there, and if you put some charge in that external field, then what type of motion your charge will show? Means what will happen to the charge? What will be its acceleration? After a given time t, what will be its velocity? What will be its velocity after a given distance s? So we are going to study about that thing, that is motion of charge in external field. I think you know, if electric field is E, charge is Q, so you can write force on the charge. Force on the charge we can simply write F will be equal to QE. And if you see this relation, This relation is present in vector form. If your charge is positive, force and electric field will come in the same direction. That is, for positive charge, force will act in the same direction of field. For example, if proton is there, if field is along positive x-axis, proton will move towards positive x-axis. But if you have some negative charge, then for negative charge, your field force due to field will be opposite to the field. So we have relation. If we know the electric field, if charge is given, we can find the force on the charge. F will be equal to QE. If your charge is positive, then force will act in the same direction of field. If your charge is negative, then force will act opposite to the field. For example, if proton and electron both are present at origin, if you apply electric field along positive x-axis, so proton will move towards positive x-axis, but electron will move in negative x-axis. Because if it is minus, you'll use minus here. So this is how we can talk about. Now due to this force, your charge will have acceleration. Acceleration, you know, acceleration can be written as force by mass. And force is QE. So acceleration due to electric field, you will get QE by m. And with the help of this acceleration, you can find everything. For example, if initial velocity is 0, I can use first equation of motion. I will get velocity after time t. I can find displacement after time t. Same, v equal to at, u is 0. S equal to half at square. Ut will be 0 because u is 0. You can similarly find final velocity after it will travel distance s. And in this situation, your path of the particle will be straight line. Here if I talk about the path of the particle will be straight line. Whatever your direction of electric field, your charge will move in that direction only. So with the help of electric field, force will come QE. If you know the value of force, you can find acceleration QE by m. If you know acceleration, you can use equation of motion, initial velocity 0, to get the value of acceleration, to get the value of v, s and v with respect to s. Now second situation. Someone said, sir, if initial velocity is not 0, then your path will have two possibilities. Either your path will be, this is the important part, question is asked from here. What type of path your charge will get? So if your initial velocity is not 0, then possibilities path can be straight line, path can be parabola. So how it will come? If your angle between initial velocity and electric field means same as direction of acceleration. If angle between your electric field and initial velocity is 0 or 180, that means force will act either in the direction of velocity or opposite to the velocity. That means path is not going to affect. That means your path will remain as straight line. But if angle is not 0 degree, not 180 degree, your path will be parabola. So just see what I am trying to tell you. If angle between initial velocity and electric field is 0 or 180, that means both will be either in the same direction or opposite direction, then path is not going to affect. Your path will be straight line. But if both are in different directions, means angle is neither 0 nor 180, except these two angles, path will be parabola. Now we'll move to how to use this acceleration again. Sometimes questions are asked where they will say you one charged particle is dropped and they will also apply electric field. So there you can use G effective. You have studied how to find maximum height. You have studied the formula for time period, in how much time it will hit the ground. So there you can use G effective. For example, you can see here, if electric field is downward, charge is also positive, that means force will act, electrostatic force will also act downward. That means net downward force will become mg plus QE. So from there, if you calculate G effective will come G plus QE by m. If electric field is upward, charge is positive, that means force will act upward. If force will act upward, your G effective will be reduced. So G effective will become G minus A. And due to electric field, your A will be QE by M. So this is how we have talked about. This time, this G effective can be used to calculate the time of flight. If you drop without electric field, time will be under root of 2h by g. If you drop and you apply electric field, if particle has charge, then you have to use G effective. Same G effective can be used for time period of pendulum also. So this is how questions are asked about motion of charge in external field. Now let's see one question based on what we studied just now from motion of charge in electric field. Now one very famous type of question is there, as you can see on the board, where they will ask you to relate proton and alpha particle. So they will say you both proton and alpha particle is a very famous type of question. Both proton and alpha particle are released from rest. They will ask you find ratio of their kinetic energy. Two things can be asked. After same time t, how much kinetic energy they will have? What will be ratio of their kinetic energy? And after traveling same distance s, what will be ratio of their kinetic energy? So you can relate very easily from here. And for that you must need to know what is proton and alpha particle. I think everyone knows. You can consider mass of proton to be m, charge of proton to be q. So mass of alpha particle will become 4m and mass charge of alpha particle will become 2q, because this is He2 plus. So charge will be 2q, mass will be 4m, this proton mass will be m and charge of proton will be q. They are asking you find ratio of their kinetic energy after time t. So for finding kinetic energy you must need to know their velocity after time t, and for velocity you must need to know acceleration. So first you can relate their acceleration. Acceleration of proton you can write qe by m. If I assume this acceleration to be a, I can also find acceleration of alpha particle. Charge 2q, so 2q into m upon 4m. Now from here if you see, this will come half of acceleration of proton. Now once they are asking you to relate kinetic energy with respect to time, that means you can write velocity with respect to time, that is v equal to at. Just now we studied. And once you put the values, value of acceleration of proton and value of acceleration of alpha particle, once you will solve, you will find ratio will come 1:1. Half mv square, half mv square. Only the thing is that here we will write velocity in the terms of time, because they are saying you the question. They are saying you after same time t. So that is how we can use ratio will come 1:1. Now in second situation, they are asking you after same distance s. So you'll be saying, sir, same thing, nothing new. But since they are asking you find their ratio of kinetic energy after traveling same distance as, same half mv square you will use. But now when you will use v as v square equal to 2as. Their time was same, so that's why you used v equal to at. Here distance is same, so you'll use your velocity in the terms of s. And I think everyone knows, with the help of third equation, we can write v square equal to 2as. So just I am using half m into v square for proton, half 4m into v square will be 2as. A we just calculated a by 2. From here if you simplify, you will get answer 1:2. Now let's talk about electric field lines and properties associated with electric field lines. So again, theoretical part but important part, questions are asked, and I think everyone knows these basic concepts related with electric field lines, but we'll revise these things. So first thing, if you look at electric field lines, always remember electric field lines will originate from plus charge and they will terminate at negative charge. Means they will start from positive charge and they will end at negative charge. That means they will never form closed loop. You will never get closed loop, never form closed loop, and hence they will be also discontinuous. This is opposite to what you see in magnetic field lines. So questions are asked where they will ask you to relate electric field lines and magnetic field lines. So always remember, if I am talking about electrostatic field lines, electrostatic field lines will originate from plus charge, they will terminate at negative charge, means they will end there. That means they will not return back. So that's why your electrostatic field lines never form closed loop, and hence they are always discontinuous. Now next property, which is important. Always remember, number of field lines is decided by charge. Number of field lines will be directly proportional to charge q. That is, n1 by n2 will be equal to q1 by q2. For example, someone says for charge of 1 coulomb, if field lines are 10, For charge of 2 coulombs, field line will become 20. So if you double the charge, number of field lines will also get doubled. That means number of field lines will be directly proportional to charge of the body. Now these field lines always propagate from high potential to low potential. These field lines will always travel from high potential to low potential. And density of field lines represent strength. For example, if you see both of these two fields are uniform, because in both you can find out field lines are parallel. So parallel field lines represent uniform field. Second thing you can see here, density is more. If density is more, strength of field will be also more. Here value of field will be more than this. That's why E2 is more than E1. And whenever these field lines will encounter any conductor, they will show some unique property. First thing, these field lines can never cross a conductor. Your field lines can never dare to cross a conductor. They will never present inside conductor. They will never cross conductor. And while originating and terminating, at one end of conductor they will terminate, and from other end they will originate. Inside they will not travel. And while terminating and originating, they will become perpendicular to the surface of conductor. This is the property of conductor. While they will originate and when they will terminate, at that time they will become perpendicular to the conductor. So these are the important properties of electric field lines from where questions are asked in your NEET exam. Now let's see some questions based on properties of electric field lines. As you can see, and these are very famous questions, some of them has been already asked in your NEET exam. With the help of these examples, I am just trying to tell you how graphically, how with the help of diagram question can be asked. So first one, they have given you field lines and they are asking you out of A, B and C, 3 points are mentioned. They are asking you at which point electric field is more, and then they are also asking you to compare the potential. If you see here at A and B, density of field lines is same. If density, and I told you density represents strength. So density at A and density at C is same, that means field at A and field at C will be equal. But at B density is less, that means field at B will be less. So that's why we can say EA will be equal to EC, because density same, so field same. So EA equal to EC, and this field will be more than B because at B density is less. If anyone asks you to compare the potential, just now you studied electric field lines always propagate from high potential to low potential. That means A will be at high potential, C will be at low potential and B will be in between them, because field lines go from high potential to low potential. So that's why we can say VA will be more than VB, will be more than VC. Now this is previous year IIT question which was asked, which you can do very easily. Now they are asking you 4 field lines are represented and they are asking you out of these 4 field lines, which field line represent correct, which field line is correctly represented. So one thing I told you just now, whenever magnetic field lines will encounter a conductor, this is a conductor, spherical ball you can say, so metallic ball. So whenever electric field lines will encounter conductor, first thing they will never cross the conductor. At one end of the conductor they will die, other end they will originate, in between inside conductor no field lines will be present. And second thing, while terminating and originating, they will become perpendicular. So you have to use these concepts to tell out of 1, 2, 3 and 4 which is correct one. So if you see first one is incorrect. This is not representing correct electric field line, because this is crossing the conductor, this is not possible. Now second, if you see, this is not crossing the conductor, but it is wrong, because while terminating, here it will terminate, here it is originating, but while terminating it is not perpendicular. We know it must be perpendicular, so that's why this is also wrong. If you look at third one you can say, yeah, third one can be correct. While terminating and originating, it is becoming perpendicular, but it is present inside. We know inside it cannot be present, so that's why third is wrong. Fourth one will be correct, that is the left one. Or you can say also, if you see these field lines, while terminating and originating, they became perpendicular and they are not present inside also. So our correct answer will be fourth one. Fourth is representing correct diagram of electric field lines. Now next question, this question you can also tell. If you see first one is wrong, you can see it is not perpendicular to the surface while terminating and originating. Second one is correct. Third one, similarly you can see third and fourth. If you see third is present inside, this is not possible. Fourth is also present inside, this is also not possible. But second is possible. It is satisfying the both conditions. While terminating and originating, it became perpendicular to the surface. And it is also not present inside. So our correct answer will be second one. So this is how we have got questions based on electric field lines. Now we will move towards relation between electric field and potential. So I think this is again a very important concept, how electric field and potential are related. So two questions are asked. Sometimes they will give you potential and they will ask you electric field, or sometimes they will give you electric field and they will ask you potential. So just see how we'll be talking about. The most basic and most famous relation which everyone knows also, that is electric field will be minus of dV by dr. E will be equal to minus of dV by dr. That means if you differentiate potential, you will get electric field. Now if your field is constant, you can write electric field directly as minus delta V by delta R. Same is this, same as that. So E will be equal to minus dV by dr. If electric field is constant, we can write electric field also directly as minus of delta V upon delta R. Now next situation, where they will ask you, now I gave you potential, I asked you electric field. So if potential is given, differentiate potential, electric field will come. If someone is saying, sir, if electric field is given, then how to find potential? So when you differentiate potential, you get electric field. That means when you integrate electric field, you will get potential. So that is what you can see here. If you cross multiply this, you will get this. Now if you integrate both sides, you can get the potential difference between 2 points using proper limit of integration. So E will be, so from here we can say E was equal to minus dV by dr. If potential is given, differentiate potential, electric field will come. If you integrate electric field, potential will come. Actually, you will get potential difference. Now, third thing from where question is asked. If you see, electric field is coming with the help of differentiation. Differentiation also means slope. So actually, electric field is minus dV by dr. And this dV by dr is nothing. This dV by dr also represents slope. So electric field will be also equal to minus of slope of VR graph. So questions are asked from here also, questions are asked from here also, questions are asked from here also. How questions are asked from the relations that we studied just now. So first type of question which exists here, they will give you potential and they will ask you find the value of electric field at a given value of x. So if you see here, your potential is depending only on x-axis. So you can directly, you know, E will be equal to minus dV by dr. Since your V depending on x, so you can write E equal to minus dV by dx. If you differentiate this, this will give you minus 2x. Now they are asking you at x equal to 1, you can put x equal to 1, this will give you minus 2. So you can write electric field vector also. If anyone is asking you vector, then you can find vector also minus 2 I cap. Why I cap is coming? Because it is along x-axis. Now see the next question and see the difference between first question and second question. If you see first question, your potential was depending only on x-axis, but here your potential is depending on x-axis also, y-axis also, z-axis also. So when your potential depends on all three axes, then in order to get electric field, we have to use partial differentiation. And I think everyone has studied. From there we will get minus, you can take common, dou v by dou x I cap plus dou v by dou y j cap plus dou v by dou z k cap. Now you can do this partial differentiation, and for partial differentiation you know x, y, z all are there. So when you find dou v by dou x, that means you have to treat only x as variable, y, z will be constant, and you know constant will not participate in your differentiation. So if you use partial differentiation, this will come. You are differentiating with respect to x, so x is variable, y, z will be constant, so they will not participate. Differentiation of x will come 1, so this will give you y, z will remain, differentiation of x will come 1, so this will become y, z I cap. Similarly here y will be variable, x, z will be constant, you can take out of differentiation, y will differentiate to give you 1, so this will become your x, z, j cap. Similarly this will become, z will be differentiated, y, x, y will remain constant, so x, y, k cap. Now they are asking you at 1, 1, 1, that means value of x, y and z all is 1. So you can put here, so from here you will be getting this electric field as minus will remain 1 I cap plus 1 j cap plus 1 k cap, 1 j I cap plus 1 j cap plus 1 k cap. If anyone asks you magnitude, you can find magnitude also. Magnitude will come root 3. Now let's move to another question. These were the question where potential was given, we were calculating electric field. Now next question, electric field is given and someone is asking you to find potential difference. So same process you have to use. You know if potential is, if you differentiate potential, electric field will come. So if you integrate electric field, potential will come. So you can use that result. You'll be simply saying, just now we studied, sir, dV will come minus of E dr, integration. Now from where to where you have to go? From 0 to 0, 0. That means here your 0, 0 will be there, and at that time what is potential? 2. So here 2. Here which point you are going? 2, 2. Here how much potential? You don't know. So you can assume x. Now if you integrate this, I think everyone knows the basic integration. This side after putting the limit you will get x minus 2, and that side after integration 2x square will give you 2x square by 2. 2 will get cancelled. So you will get x square, limit will be from 0 to 2, and here minus, don't forget this minus, otherwise your answer will change. Similarly 2y integration will give you 2y square by 2. So again 2 will get cancelled, so you will get plus y square. From where to where? 0 to 2. Now you can put the limit, this will come x minus 2, that will come minus there, 2 square will give you 4, here also 2 square will give you 4, 4, 4, 8. So minus 8, this 2 will go that side, so it will add. So value of x will be coming as, this is minus 8 plus 2, you will get minus 6 volt. So this is how questions are asked based on differentiation and integration. We are going to study about electric flux. So what is meaning of electric flux and how question can be asked from electric flux. So first thing, electric flux represent number of electric field lines crossing a given area. So that is the meaning of electric field lines. That is the meaning of electric flux. Electric flux represent number of electric field lines crossing a given area, and mathematically we define electric flux as integration E dot ds. But you will not get any situation where you will need integration, because always you will find that E will be constant. So that's why without integration the formula which we will use, which will be useful for us, will be flux equal to E dot s. This will be used for us to calculate the value, or you can also write as Es cos theta, where E is your electric field vector, S is your area vector. And you must know what is direction of area vector. Your area vector will be always perpendicular to the plane of object. For example, if anyone says your object is placed in xy plane, so area vector will be perpendicular to that plane. Perpendicular to xy plane will be your z axis. So mathematical practical meaning of flux. Electric flux represent number of electric field lines crossing a given area. Mathematically, flux will be E dot S or Es cos theta. Where S is your area vector, you must know direction of area vector. Area vector will be perpendicular to the plane. And theta represent angle between E vector and S vector. For example, just see here. If you see this situation, here you are having one square plate or one plate like this, one loop like this. Now electric field lines are like this. These are your electric field lines. Someone is asking what will be the flux through this loop. So we'll be saying flux through this loop. For flux you need to know Es cos theta. So if you see E vector is like this, S vector will be perpendicular to the plane. So what is angle between them? Angle between them will be 90 and cos 90 will be 0. That's why in this situation you will not get any flux. Second situation, if you see, area vector is also perpendicular to the plane. S vector is also perpendicular to the plane. So angle between E and S here will come 0. So cos 0 will be 1. So that's why you'll get maximum flux E into S. Now some questions are also asked where we have to use E dot S. For example, just to tell you, I have got one question here. In this question, they have given you electric field vector and they are asking you find the flux. So again for this, you know sir, for solving I know sir, I can write flux will be equal to E dot S. E vector is given but S vector is not given. You have to find S vector by using concept of your area vector. So I'll be first saying, sir, this is a square loop, side length is 2. That means its area will be 2s square, area will be 4. And since it is placed in yz plane, so you must know area vector will be perpendicular to your yz plane. So who will be perpendicular to your yz plane? That is your x-axis. So we'll be saying, sir, from here E vector is given, S vector I can find. S vector will be magnitude into direction. What is magnitude of area? Area will be 4 because square side length 2, so area will be 4. And its direction will be perpendicular to yz plane. Perpendicular to yz plane means your x-axis. So your S vector will come 4i cap. Now E vector is there, S vector is there. If you do dot product, you will get the value of flux. And I think everyone knows how to do dot product. I will give dot with I. So 3 into 4, you will get 12 units. So this is the value of flux that we will get here. So this type of questions are asked from vector result. This type of questions are asked from Es cos theta. Now we will study about Gauss law. And after studying Gauss law, we will relate electric flux that we studied just now and Gauss law. So I think you know Gauss law will be equal to, with the help of Gauss law we can find the flux associated through any surface, through any closed surface. So Gauss law says us flux through any closed surface will be equal to Q enclosed by epsilon naught. You have to see the total charge present inside. You have to see Q net enclosed by epsilon naught will give you the value of flux. So this is Gauss law. According to the Gauss law, total flux associated through the closed surface will be equal to Q net enclosed upon epsilon naught. For example, if you see in this diagram, someone is saying, sir, I am having a closed surface of any random shape. Someone is asking you find the flux through this closed surface. So you'll be saying, sir, with the help of Gauss law we can find this flux. Because we know, sir, flux through any closed surface will be equal to Q enclosed by epsilon naught. So you have to see the charges present inside. This charge you don't have to see. You have to see only the charges which are present inside. If you calculate the total charge present inside, 3 plus 1, 4, 4 minus 2. So total charge present inside will be 2. So flux will come 2 by epsilon naught. So with the help of Gauss law, we can find the flux that is Q enclosed by epsilon naught. But if you see, just now you studied, sir, flux is also E dot S. And by Gauss law, flux is also Q enclosed by epsilon naught. That means from there we can write, you see, flux, just now studied, flux will be written as E dot S. And just now with the help of Gauss law, you got to know flux is also Q enclosed by epsilon naught. That means with the help of Gauss law, we can find electric field. That is, flux is also Q enclosed by epsilon naught. Flux is also E dot S. So you can equate these two. But while equating, always remember, here electric field will come due to all charges. This is the most important conceptual point in Gauss law. When you calculate electric field with the help of Gauss law, you write E dot S will be equal to phi, phi will be equal to Q enclosed by epsilon naught. So always remember, E represent field due to all charges. Whether present inside or outside doesn't matter. Electric field will be due to all charges, inside as well as outside. But Q enclosed will be only due to inside. So this is how we have talked about. So in Gauss law, when you write E dot S, always remember electric field is due to all charges, present inside, outside doesn't matter. But for Q enclosed, you have to take only charges present inside. Now, for example, someone said, sir, I have a closed surface placed in external field. Some closed surface is there, it is placed in some field. So here what will happen? You will get inward flux also, and you will get outward flux also. You will get incoming flux also, you will get outgoing flux also. So net flux you can write phi out minus phi in, and that will be also equal to again net flux, and net flux will be equal to Q enclosed by epsilon naught. If someone says inside no charge is there, so Q enclosed will be 0. That means phi net will be your 0. So that's why we say if a closed surface do not have any charge present inside it, then net flux associated through it will be always 0. If you place it external field, net flux will be always 0, because whatever the electric field lines will enter, same will go out. Incoming flux will be equal to outgoing flux. So that's why net flux will be always coming 0. So net flux you can write phi out minus phi in. That will be also equal to Q enclosed by epsilon naught. If Q enclosed is 0, net flux will be 0. Now let's see few situations where you can find flux with the help of Gauss law. And all these situations are important, maybe asked directly in your NEET exam. So see here how questions are asked. For example, first question which is asked here, they will say you have a sphere, charge Q is present inside the sphere, and they will ask you find the flux through the sphere. So you can find very easily. You know flux will be equal to, sir, Q enclosed. What is charge enclosed? Q by epsilon naught. This is the flux in first case. In second case, they will again ask you find the value of flux. Now if you see, this is hemisphere. So you'll be saying, sir, in order to completely enclose the charge, we need one more hemisphere here. That means if total hemisphere is there, then if total sphere is there, flux will be Q by epsilon naught. But here only I have half of the hemisphere. Half of the sphere I have, that is hemisphere I have. So only half of the flux will go. So here if anyone asks you value of flux, here you will be getting flux as Q enclosed is Q by 2 epsilon naught, because total flux will be Q by epsilon naught, but that will be shared equally by upper half and lower half. So I am only talking about upper half. So flux will become half, that is Q by 2 epsilon naught. Now in this situation, now again this is an important situation, you have a cube and charge is placed at the center of the cube, body center. That means obviously this charge is completely enclosed inside. So here you will be getting flux as, flux through the whole cube will be coming as Q by epsilon naught. But here they may ask you find the flux through each face of the cube. So obviously all the faces are situated symmetrically from the center of the cube. So each will share equal. And I think everyone knows cube will have 6 faces. So each face will get flux of Q upon 6 epsilon naught. 1/6 of this, because equally shared by all 6 faces. Now let's see the next situation. Here you have placed the charge at the face center. That means face center you have placed. That means in order to completely enclose this charge, you have to put another cube. If you put another cube like this, someone says, sir, if I put another cube in this manner, then this charge will be completely enclosed. So flux through both of the cube together will come Q by epsilon naught. But I have only one cube. That means half will be shared by this cube. So here flux due to flux for this cube will become half of Q by epsilon naught. that is q upon 2 epsilon naught. Now in this situation, you have charge at the vertex. Now you know in this situation what will be your they will again ask you what is the flux through this cube. You know, in order to enclose this charge completely, you will need 8 cubes. One cube like this, one cube from this side, one cube here, and one cube, 4 cubes from the top. Or you have studied in chemistry also, if any sphere is there, its contribution will be only 1/8. If molecule is there, then contribution will be only 1/8. So you'll be saying, sir, it's only q by 8 will lie inside this cube. So flux will also become 1/8, that is phi will be coming as q upon 8 epsilon naught. Now let's move to next situation. Here someone asked us, find the flux through this square. This is a square plate, as you can see. Now you will be saying, sir, how to find flux through it? So again you will be saying, sir, if you put 6 identical square plates like this, you will get a cube. And this charge will come at the center of cube, same as this. And this will behave as one of the face. So flux through it will become again q by 6 epsilon naught. So these are how questions are asked related with value of magnetic flux, value of electric flux with the help of Gauss law. Now we will revise value of some important electric field obtained with the help of Gauss law. And we are not going to derive them because you have already derived them. We are just revising those values. So first situation which is calculated with the help of Gauss law. If you have an infinitely long line charge of linear charge density lambda, so due to this at a distance r, value of electric field produced will be lambda upon 2 pi epsilon naught r. If you have infinitely long, for example, if I have an infinitely long line charge, so due to this, at any distance r from here, value of electric field produced will be lambda upon 2 pi epsilon naught r. And you can see E will be inversely proportional to r. So if graph is also asked, you can draw the graph also. E and r are inversely proportional, so you'll get graph like this. That is hyperbola you will get. And if it is positive line charge, then field will be again away. If it is negative line charge, field will be towards. Similarly, if I have an infinitely large plane sheet of charge, then value of electric field due to this at a distance will be at any distance, because here value of electric field will be constant. It will not depend on distance because you know the value. E will come sigma upon 2 epsilon naught. If someone is saying if it is positively charged, then same field will come away. If it is negatively charged, field will come towards. Now third situation, if someone is saying, sir, if I have an infinitely large conducting surface, if I have a that is infinitely large plane sheet of charge, means only one surface is there. Here conducting surface is there, infinitely large. So value of field will come sigma by epsilon naught. Again, if this charge density will be positive, field will be away. If it is negative, field will be towards. And if you see both situation, in both situation field is constant. It will not depend on distance. Now fourth situation, if you have any surface of any shape, doesn't matter. And if anyone asks you what is the value of electric field due to that surface, due to that body, very close to the surface. So if you go very close to the surface, it will start behaving as infinitely large conductor. If you go very close to the surface, for example, here if charge density is sigma, and if you go very close means distance between your point and this surface will be 0. If distance will be 0, you can think it will become like infinitely large surface. And for infinitely large surface, you know the value of electric field, sigma by epsilon naught. So here also electric field will come sigma by epsilon naught. So first situation, infinitely large plane sheet of charge, lambda upon 2 pi epsilon naught r, graph will be hyperbola. Here also if you want to draw the graph, you can draw the graph, it will come straight line. Plane sheet of charge sigma by 2 epsilon naught, it will not depend on distance. Third situation, conducting surface sigma by 2 epsilon naught here, conducting surface sigma by epsilon naught. Again if you draw, it will come straight line. If you have any surface, shape doesn't matter. If you go close to the surface, surface will behave as an infinitely large conducting surface. And for infinitely large conducting surface, we already know sigma by epsilon naught. So here also field will come sigma by epsilon